Welcome to today's webinar, Farming for Carbon Capture Using Cover Crops for Climate Resiliency. Today's special guest speaker is Dale Strickler. This event is presented by republicEn. We are a nonprofit organization for conservatives who want to solve climate change through common sense market solutions. We're also often known as the eco-right. My name is Angela Lark, and I am republicEn's Digital Engagement Specialist. Thank you all so much for being here today and being part of this important learning session. Just to give you a quick rundown of what's happening, we're going to start off with a brief introduction and welcome, and then we'll head straight into our speaker presentation. After the presentation, we'll have plenty of time for questions and answers. Is there anyone here that is using Zoom for the first time? Do we see anybody out there waving their hands or putting something in the chat? All right, let's all refamiliarize ourselves with the chat feature. So let's take a minute and say your name and what city and state you're tuning in from. And I will go ahead and start us all off. So I am Angela, and I am in Cincinnati, Ohio. All right, so let's see. I see Westfield, Indiana. Another person in Carmel, Indiana. California, Maryland, Michigan, New Jersey. So lots of different places here, and it looks like we still have people coming in and joining us too. Losing you guys.
There's a familiar person there.
Awesome. So in the chat is where we encourage everyone to submit their questions and comments. So please feel free to submit a question to Dale at any time during the presentation. So what's going to happen is during the presentation, as you're putting questions in the chat, republicEn staff will be collecting all of those questions. And at the end, we'll go through the questions one by one as time allows to get until the end of our webinar hour. Does anybody have any questions before we move on? If you do, throw them in the chat. All right, I'm not seeing anything. So now I would like to pass the mic to former Congressman and republicEn Executive Director Bob Inglis, who is going to say a few words. Oh, Bob, we can't hear you.
There, now I can, now I was allowed to unmute myself. Welcome everybody, and thank you for joining us. You know, there's a lot of interest in natural solutions to climate change, and we at republicen.org share that interest. Particularly, we are interested in how to make those solutions economic. And that's what I hope that Dale is going to be able to help us with here tonight. There's some exciting things that can be accomplished through farming practices that we're about to hear about that help with climate change and improve our food supply, improve the quality of food as well. So it's very exciting to have Dale with us, and it's exciting that you've joined us. So looking forward to his presentation, to your presentation, Dale, and to the questions that will come and we'll hopefully have a great evening together. So thanks a lot, everybody, for coming. And now I'm going to pass it off to Chelsea, who is Chelsea Henderson, our podcast host at the Eco Right Speaks, who has interviewed Dale, if you're up to date on your podcast listening. And so, Chelsea, take it away.
Good evening, everyone. Thank you so much. I'm not used to doing these live recordings, so hopefully I won't mess anything up, but I wanted to give a warm welcome to our guest tonight, author and consultant Dale Strickler, who has more than 30 years of experience in agronomy, pasture management, soil and crop advising. He has developed highly effective grazing systems for numerous ranches with a range of often challenging climates and soil types, which we're seeing more of lately, those challenges posed by climate change. Dale also designs crop rotations and advises on cover crop planning to improve soil, maximize crop yields, and reduce the need for expensive crops inputs. He currently serves as the lead agronomist for the nation's premier cover crop specific seed company. And as you're seeing tonight, is a featured speaker at many conferences, webinars, grazing schools around the country, and now, thanks to Zoom globally. As Bob just mentioned, he was an Eco Right Speaks podcast guest earlier this month. If you missed that episode, I encourage you to go back and listen. If you have other things you might want to hear from him, we certainly found his work exciting and fascinating as it relates to climate change, which is why we invited him to join us today. So without further ado, I will turn it over to Dale Strickler.
Thank you very much. And I am tremendously excited to be here. I am going to share my screen here. I wanted to make sure. Can you folks see my screen? Okay, good deal. So, I mean, obviously, ordinarily I start a presentation like this explaining the climate situation. And with this audience, I don't feel I need to do that. We all understand the reason you're members of this organization is because you know the gravity of the situation. But just like when you go into your doctor's office and they say, he says, or she says, you have a problem, you know, you want to know how big is the problem. So we all know that climate change, we're told that climate change is caused by carbon dioxide in the atmosphere. And right now, there is about 875 billion tons of carbon dioxide in the atmosphere. About 240 billion of those have been added since the beginning of the industrial age, roughly 200 years ago. Where'd it come from? Now, obviously, you know, we're told that all came from fossil fuel use, but that's not exactly true. A good chunk of the carbon dioxide that's currently in the atmosphere did not come from the burning of fossil fuel. It came from the tillage of soil, mostly on the North American continent. Since the settlement of the United States and Canadian prairies, soil tillage, as I show here, soil tillage oxidizes carbon compounds in the soil and turns them into CO2, and they go up into the atmosphere. And the legend on this MBP here stands for moldboard plow. You know, the device that John Deere invented, 100 and however many years ago, nearly 200 years ago, that when you convert prairies into cropland, you lose soil carbon as carbon dioxide. And the other bars here, this red bar is the approximate amount of carbon added back to the soil in plant material every year. And you can see that when you plow that soil, you have more carbon dioxide leave than is added back in a cropping system. This far right column, the NT stands for no-till. This is where you do no tillage at all. And so it's a newer type of farming than what we've done historically. Plowing has been part of the way we farm. Tillage has been the way we farm for really about the last 8 to 10,000 years, and it's spread across the planet. And it has caused massive destruction. And we've always thought that that's the only way we can farm, but there are different ways of farming. So if we want to reduce carbon dioxide in the atmosphere, one way, of course, is to stop emissions. Let's stop fossil fuel. Let's quit burning fossil fuel. Well, that's one way. But if that's all we do, how do we get rid of the current carbon dioxide in the atmosphere? We have all this legacy CO2 up there. What do we do about that? Well, let's pull the carbon out of the air. How do we do that? Well, we can commission the world's best engineers, and they can design a machine that will suck carbon dioxide out of the air and put it into the ground. Let's have $1 million prize for designing something like this. Well, I'm going to win that prize because I have devised a machine that will not only pull carbon dioxide out of the air and put it in the soil, it'll run completely on solar power. It's biodegradable, it's recyclable, it's human edible, and it creates its own replacement at the end of its lifetime. And it runs entirely on solar power. It's a plant. This is how the world is supposed to work. Basic botany is that plants take CO2 out of the air, water out of the soil, turn it into C6H12O6, which is sugar, glucose, and oxygen, which is necessary for animals. 2 basic requirements for animals to live. And they're provided to us through solar power and rainfall and CO2 in the atmosphere, and it creates all the necessities of life. This is how the world is supposed to work. And then that sugar is put into the roots of plants, and plants give off about 25% of the sugar they produce as root exudates. All these little droplets you see coming out of this root tip, those are root exudates full of sugar. And plants do that to feed microbes in the soil. And then these microbes create this miraculous carbon-based compound called soil organic matter. And soil organic matter is what turns rock powder into soil. This is the difference between geology, just powdered up rocks, and soil. If you are growing a garden, which of these 2 soils would you prefer? The lifeless one on the left, or the rich, black, moisture-holding soil on the right? Which would you prefer if you're going to pick food grown in either one of these soils? Which would you prefer? I think everybody would prefer the rich soil on the right. I collected these 2 soils across the road from each other. And in a moment, I'm going to tell you the difference between these 2 soils. And it's all simple management. How do you turn the one on the left into the one on the right? And simultaneously, how did all this carbon get in the soil on the right? This is a soil rich in soil organic matter. Okay, so what is the potential of simple changes in our agriculture methods for taking CO2 out of the air and putting it in the soil? So here's worldwide, there's about 4 billion acres of cropland, about 16 billion acres of pasture and rangeland. And typically pasture and rangeland is land that cannot grow crops. It's too rocky, too droughty, too something to grow crops. And so the next best way of producing food from those acres is through grazing livestock. We'll talk a little bit about that. So let's do some carbon math here. Okay, if you increase the soil organic matter in just the top 6 inches of soil on an acre, that is 10 tons of soil organic matter from just a 1% increase in soil organic matter. So 10 tons of soil organic matter will pull 18 tons of CO2 out of the atmosphere. Okay, so if you take 20 billion acres worldwide, increase the soil organic matter 1%, that takes 18 tons per each 1% organic matter. That's 360 billion tons of CO2 taken out of the atmosphere. And remember, since the Industrial Revolution, we've done 240. If you can raise soil organic matter on all agricultural soil around the world by 1 percentage point, you will take 50% more CO2 that's been added from fossil fuel, tillage, all sources combined, out of the atmosphere and put it in the soil. Now, how feasible, how practical, how economical is it to raise soil organic matter 1%? And what's the downside? So, okay, so other than stop climate change, what else does increased soil carbon do? What's the downside? Well, okay, let's take a look at what it does in addition to prevent climate change. Well, it reduces flooding. It reduces the effect of drought because water goes in the soil and it's held in the soil. It makes the soil more productive, so we have more food and less famine. And less famine means there's less strife and less warfare. And more productive soil means more prosperous farmers. And I'll talk about what more prosperous farmers means for the economy in general. It makes cleaner air. We don't have dust blowing around. Makes cleaner water. We don't have sediment getting to our water. The muddy Mississippi is now the clear Mississippi. It makes for a more reliable water supply instead of flood and drought cycles. We have a slow, steady supply, which replenishes our aquifers, and it makes a slow, steady supply in our streams and rivers. And it makes healthier food, because one of the ways that food becomes healthier, full of phytochemicals, full of vitamins, full of minerals, is by absorbing microbial byproducts. How do you create more microbes in the soil? A good, healthy soil will be full of beneficial microbes, probiotics. You do it by feeding them, and you feed them through those root exudates that make soil organic matter. And it makes healthier ecosystems and more abundant wildlife. I mean, I love wildlife of all forms, not just white-tailed deer. I love salamanders, lizards. I mean, this makes a happier planet, a much more pleasant place on which to live, and that our grandchildren will live on. So what's the vegetation type that does the most to put carbon in the soil? Most people, if you ask this, they'd say forest. And everybody knows if that cutting down forest to grow crops takes us backwards as far as climate, because a forest has a lot of carbon stored in those tree trunks. But a forest may take multiple decades to do that, to store all that carbon. A grassland, on the other hand, can store it really rapidly. Within a decade, you can store a tremendous amount in a grassland. This is some reseeded cropland. And why can perennial grasses that live year after year after year, do so much for soil? It has to do with the roots. Soil organic matter is made, remember, by root exudates. So the bigger the root system you have, the more carbon you can put in the soil. And what I have here, this is a photo from the Land Institute in Kansas. If you're not familiar with the Land Institute, you need to read up about it. It's truly amazing. So in September, the plant, each of these months, the September, December, March, June, to the right is a perennial grass. To the left is wheat. In September, wheat hasn't even been planted. There is no root system there, no root exudates. In December, there's a small root system. And then March, it's a little bigger. And in June, that root system is dead because wheat ripens in June. And then the entire summer, there's no root exudates. But that perennial grass is producing root exudates every single month of the year. And a lot of them. Look at the difference in volume. That root system on that perennial grass is 3 meters deep. That's 10 feet. The wheat roots go about 1 meter. That's not much. So perennial grasses are the way of building soil carbon if you really want to get serious about building soil carbon. But remember, almost all those grasses come from, or all the soil carbon comes from the roots, not so much the tops. You look at all this luxurious growth, and that's all made of carbon, but it doesn't really change into soil carbon because microbes that do the conversion, they need it to be warm, they need it to be dark, protected from ultraviolet light, they need it to be moist, and they need their food mixed together in liquid form because they can swim, but they can't walk. They can't run, they can't fly, but they can swim. So, we talked about a machine that would suck CO2 out of the air. I would like to have a machine that can change all this above ground carbon into soil organic matter. And I want a machine that'll take all this material, grind it up, moisten it, put it into a fermentation vat, keep it warm for about 24 hours, and then deposit that fermented material back out onto the land as permanent soil organic matter. Oh, and because I am an environmentalist, I want this machine to also be solar powered. I want it to be recyclable. I want it to have a 3D printer on it so it creates its own replacement at the end of its life cycle. Solar powered, and let's make it recyclable. In fact, let's make it recyclable as human edible protein that's so delicious that entire restaurant chains spring up around it. And of course, what I'm talking about is a cow or any ruminant animal. It doesn't have to be cows. It can be sheep, because once you create those conditions where microbial fermentation can occur inside a ruminant animal, which is a 4-legged fermentation chamber, you can convert all this inedible to humans material into delicious, nutritious, environmentally friendly protein concentrate. But just any old grazing method, grazing is good for land, grassland is good for the land, but there is a huge difference in how it's managed on the results you get, because this is what a typical grassland looks like after grazing. Animals like tender, young regrowth of grasses. They don't like old, tall, mature rank grasses. So this is what a grassland tends to look like at the end of the grazing season. This grass wasn't grazed at all. It contributed nothing to the rancher profitability here. This grass was grazed too hard. It has no leaf area to perform photosynthesis. It's weak and does not contribute to soil organic matter. So you would prefer to have all that grazed equally, each grass grazed 50%, not one 100% and one 0. How do you accomplish that? Well, there's a little management trick, and it's called, rotational grazing, savory type grazing, intensive management grazing. We'll call it, for all our purposes, let's call it AMP grazing, adaptive multi-paddock grazing. You concentrate animals in a small area, graze them down to 50%, and then you move them, and you keep rotating them around until the grass is at the proper stage to be grazed again, and you give it rest in between. And what that does is, compared to continuous grazing, which is how we've grazed for centuries, to AMP grazing, look at the difference in soil organic matter. we're talking as much as a 10-fold increase in soil carbon content because you're optimizing photosynthesis, which optimizes root exudates, which creates soil organic matter by feeding microbes. What does research say about this? Here's several research trials that's been done around the country. And this is the amount of carbon that has been stored in several different ecosystems. This is the increase in tons per hectare per year, tons of carbon per hectare per year over, the stated period. Here's another trial. All these, if you look at the average of these trials, this is from Alan Williams, formerly of Auburn, and these averaged about 2% soil organic matter. And at the end of just 5 years, when they changed to this managed form of grazing, it went to 4%, doubled. And remember, how much did we need to suck all the CO2 out of the air? We needed 1%. In just 5 years, this did double that with just a simple management change. And, when we talked about, well, what else does this do? Well, here's rainfall infiltration. And this green bar is these green bars here on all these different research sites. This is the infiltration rate of rainfall, how fast rain goes in the soil. If water goes in the soil, where does it not go? It doesn't go down the hill, into the streams, into the rivers, and cause flooding. Flooding is the single most expensive natural disaster that we face around the planet. Floods cause catastrophic damage. If you increase the infiltration rate on all these soils, flooding ceases to be a problem. But wait, there's more, not a ShamWow or a Ginsu knife, but there's more. There's other benefits here. You reduce nitrogen that moves off of land and into rivers. Say, why is that important? Because nitrogen can create toxic compounds in drinking water. So this makes for clearer water. This AMP grazing over here, just to tell you what this is, this HC is heavy continuous grazing. The next one is light continuous grazing. So, overgrazed, lightly grazed, and then managed grazing. And the exclosure is no grazing. So this managed grazing has no more nitrogen going into the water than, if you look at the statistics here, this little bar, if you know anything about how statistics are, there is no difference between these two. And phosphorus. Phosphorus also causes issues in water. And again, the best situation, the best grazing management situation was this AMP grazing, this managed one. And it also, if you see this, this is after they changed to AMP type grazing. This is the amount of animals they're able to carry on this ranch. It went up 4-fold. That's more protein going into the human food supply with just this little simple change in management. Not buying expensive fertilizer or buying some new machine. A simple change in management increases rancher output 4-fold in this case. And then cropland, what can we do on cropland? You look at this beautiful cornfield, and obviously there's photosynthesis going on there. But what happens after harvest? Like here, this is a harvested wheat field. And typically that wheat field would sit idle, oftentimes for months. Western part of the United States, it might sit like that for almost an entire year, waiting for the next crop to be planted. There is no photosynthesis going on here. There is no carbon being pulled out of the air. This is also crop stubble, but this has a cover crop on it. And the cover crop, the definition of a cover crop is it's a crop planted solely for the purpose of soil improvement, or for the primary purpose of soil improvement. Because remember, photosynthesis, root exudates, microbes, that sequence is what makes soil better. And when you understand that, it makes a lot of sense, not only for the climate, but also for the soil, and everything else that soil carbon does is to plant cover crops to put carbon in the soil. How effective is it? This is a study that this was a 6-year research trial in Kansas, and just 6 years, look at this, about a 50% increase in soil carbon in the topsoil. 50% increase in just 6 years. How amazing is this? And you can even establish cover crops prior to the harvest of the previous crop. So it's like a relay race. Before one crop finishes, you've got the next one started. So photosynthesis continues uninterrupted. This is a cover crop that was seeded in between rows of corn prior to corn harvest. So this corn is just drying down. It's not photosynthesizing, but this cover crop below it is. And then other benefits of the cover crop is not just putting carbon in the soil. This is a cover crop that was allowed to grow up really big. It's being, then the cover crop is typically killed in a vegetative state so that it's full of protein and nourishes soil microbes. And it creates what we call soil armor, protection for the soil. When you coat the soil with this layer of residue, it really accomplishes some tremendous things. And one benefit is encouraging infiltration into the soil. And so water goes in instead of running off. Again, we're stopping flooding. But here's a bigger one. This has real implications for climate change. So this is a thermometer that monitored the air temperature on one of our field days. One of my coworkers took this with a green cover seed. This is the soil temperature. This is the temperature of bare soil on the same day, 20 degrees hotter. This is the temperature of cover cropped soil on the same day, 20 degrees cooler, 40 degrees cooler roughly than the bare soil. When you have all this out there, how do you think of millions of acres? What does bare soil do? Remember what happened about a month ago in New Mexico? 341 acres burned. This is a rainfall map. Look where there's bare soil creates heat domes. Bare blackened soil creates heat domes that drive rain away. When you have bare soil, there's all kinds of mechanisms. Climatologists can explain this, but you get a reduction in rainfall. And this is catastrophic. You return rain to the environment by vegetating that land. So I'm going to skip some of this stuff here in the interest of time. Another benefit or another means of adding soil organic matter is through certain microbes called mycorrhizal fungi. And all these little filaments here, these little threads coming out of this plant root are mycorrhizal fungi. Mycorrhizal fungi live on plant roots, live off those root exudates, and they produce a compound called glomalin, and it glows in ultraviolet light, which is why it's visible here. That is the most persistent soil carbon compound we have. Lasts very long, it's very powerful. And this organism also creates drought tolerance. Mycorrhizal fungi applied to this corn crop to the right, none on the left. And if you really, really want to get serious about increasing soil carbon, you take cropland and you plant it to pasture. We talked about grazing management on existing pasture, but if you really want to sequester carbon, take cropland, plant it to pasture. And I'll show you, here's a research trial where they did that. And you can see, wow, 8 tons of carbon per hectare per year. Let me show you my own experience. This is from my own personal farm. I dug a trench out in the field And here's before, it was 1.9% organic matter, which is typical for my area, roughly 2%. The roots of my crop went 18 inches deep. So what I did is I stopped raising corn, stopped raising soybeans, planted perennial grasses, inoculated with mycorrhizal fungi, and did AMP grazing. And this is that pasture restored prairie. I'd love to show you, if I had time, I'd show you pictures of all the tremendous variety of wildlife I had here. But this is after 8.7% organic matter, not 1% increase. In 15 years, went up 7 points. That's just ridiculous. So how do we make this happen? Well, I think the first thing we need to do, we need to change some policy. And that's why I'm so excited to work with you guys, because that's what you guys do. You change policy. We need to remove the barriers to soil carbon sequestration. And one of the big barriers is federally subsidized crop insurance. Farmers that till their soil file 30% more crop insurance claims than people who no-till. And people who cover crop historically have been denied crop insurance. And if you're denied crop insurance, you can't get a loan from the bank to operate your farm. So there's been active discouragement of these practices by crop, USDA policies that date back to the Great Depression, before we ever developed any of these practices. So why do farmers who no-till have to pay the same crop insurance premiums as those who till when they file 30% fewer claims? Maybe we need to change that. And then if you want to change behavior, there are carrots and there are sticks. So this is soil that washed off a field and covered up the road, and that soil had to be removed at taxpayer expense because that field was bare and had no cover crop. It was intensively tilled, and taxpayers had to pay for that removal. Should this person be fined? Should those fines go into a fund that pay people to cover crop? And I'm glad Jamie Powers is on here. He is with the organization RIPE, Rural Investment to Protect Our Environment. They are an organization similar to yours who is proposing that the federal government pay farmers $100 an acre to cover crop, or $100 per animal unit, which would be like a cow. An animal unit is equivalent to a cow, or 5 sheep, 5 goats, to do AMP grazing. And so can we afford that? As a conservative organization, we're loath to spend a lot of government money. We try to come up with solutions. Well, this is what we spent on the pandemic. If you add all this up, that's $5.7 trillion divided by 450 million acres of cropland. That's $12,000 an acre. And the average purchase price of cropland in the United States right now is about $3,000. What we spent on the pandemic would buy every acre of cropland in the US 4 times over. That's $17,000 per person in the United States. 4-person household, $68,000. So, and the nice thing about this, and I am wrapping up, Angela, I am winding down here. So the nice thing is where does this money go? It goes to the bottom level. And I'll have to disagree with Ronald Reagan here. I don't believe we have a trickle-down economy. The economy is not created at Wall Street. It's not created in corporate boardrooms. It's reflected. Everything comes to us from farming, fishing, forestry, or mining. It all comes from soil and water. And then every other economic run adds price to that. That is how economies are created. When you return economic prosperity out to people who are primary producers, farmers, fishermen, foresters, miners. That is how you create an economy from the ground up, literally from the ground up. So you did, Chelsea, thank you for mentioning my books in the deal. This is one of the books, and there is my information. So and I could, if you can't tell, I love this stuff, and I could talk about it all night long, but I know we have to get on. So Chelsea, Angela,
Well,
who's
thank you
taking
so
over here?
much for that, Dale. Yeah, no, that was really informative. And I thought I learned a lot on the podcast, but I feel like I learned even more watching your presentation. And you had noted that when we were talking that this was your sweet spot. So we definitely had some questions pop up, and I'm going to marry those with some that I have. And obviously the other members on the republicEn.org team might want to weigh in as well. One of the questions that immediately came to mind for me, and someone wrote something similar, is I was wondering whether all plants or all cover crops are created equal, or certain ones going to be better than others. And one thing that one of our guests tonight asked is whether you could recommend cover crops that don't become invasive species, especially for those of like her or him that live in border prairie remnants. So I will let you take it away with that.
Oh, absolutely. Some cover crops are definitely better than others. But they all have different purposes. I mean, if one cover crop was the best, it would be the only one. And my employer, Green Cover Seed, would not have 150 different species in the warehouse. It'd sure make managing inventory a lot easier, and it'd make my job a lot easier. I wouldn't have to have an hour-long conversation with a customer. I just say, buy this, done. So, sorghum sedan grass is a perennial that acts like an annual. It grows as fast as an annual, but has the monster root system of a perennial. And because it grows very, very fast, establishes quickly, that's probably my most favorite cover crop. But it doesn't produce nitrogen. You need legumes to make nitrogen. And so where you really get soil improvement, it's like saying, what's the most nutritious food? Remember, we're trying to feed microbes with these cover crops. You can't live on just one type of food. Maybe you've heard of rabbit starvation. Rabbits are high in protein, but they supply no carb. You will starve to death on a diet of only rabbits. You need to have a diversity of diets. So do microbes. They need proteins, fats, carbohydrates, minerals, vitamins, just like we do. So you get the most soil benefit from having plant diversity. You have legumes, you have grasses, you have summer cover crops, you have winter cover crops. People say, what's the best cover crop to plant? I said, all of them. You get diversity, you get a blend, and there is very strong synergy. You look at nature, the only place that there are monocultures on the planet are where people have planted them. Nature always farms in a polyculture because diversity of plants creates synergy and benefits a wide variety of wildlife, and you don't have all your eggs in one basket that way. Monocultures just get wiped out by diseases and insects in nature. When we have monocultures in agriculture, we control insects with insecticides. We control diseases with fungicides. Nature doesn't have that option. And so nature does not have monocultures. And so
that reminds me, Dale, of I made fun of myself a little bit for suggesting this on our podcast episode together, but I learned some of what you taught me and have seen some of these lessons in my own attempts to garden and to no longer have a suburban lawn, which was a question that came up, and had the very nice local Audubon volunteers come and walk around and give me suggestions. And basically what you're saying about monoculture versus polyculture is one thing that they brought up. You need to have things that bloom at different times and that are different heights and provide different food sources for the, the pollinators and so forth, which I know we're veering a little from the ag side, but a question did come up about how you could apply this to suburban lawns. And I think, that is something that I feel like is the biggest scam perpetrated on people, is that we have to have these pristine lawns and you have to water them and mow them and seed them and kill everything, or, using insecticides and pesticides. And so anyway, if you have an idea on any recommendation for suburban lawns so people could put these practices into use at home, I think that would be
Thank you for asking. There are 40, last I saw, if I remember correctly, 41 million acres of lawns in the United States. To put that in perspective, I believe there's 80 million acres of wheat. We have half that, 50% of that in lawns that produce nothing, but they consume more fossil fuel per acre than our cropland does to produce nothing, except a lot of CO2 emissions from frequent mowing. There is more fertilizer applied per acre to the average suburban lawn than there is to a corn crop. There is more water applied per acre on the average to the average suburban lawn than to an irrigated corn crop, and it produces nothing. Now you can replace lawn, and I think the what do you call them? The homeowners associations are one of the biggest barriers to progressive lawn management for climate. We should really start seriously replacing lawns with either gardens that are farmed with cover crops and no-till. And I think that's a very exciting frontier. Or with restored, like you're talking about, Chelsea, with restored prairies of perennial, big, tall, perennial warm season grasses and wildflowers that nourish wildlife, and stop spraying insecticides. We are in grave danger of losing our insect population. If you haven't heard the term insect apocalypse, you need to look that up. It is really scary, really, really scary. We are losing our insects, and insects are at the basis of a good chunk of our entire ecosystem food chains. And that's a scary, scary prospect.
Yeah, don't get me started on Mosquito Joe. I could do a whole webinar. Maybe that'll be what we do next, Angela. Another question from our participants tonight. Ruminants sound good for carbon capture. However, they also release methane, which is negative for climate change. What is the balance between the two, and how can methane be reduced?
There are no more cattle on the planet than there were 10,000 years ago. Why is it that all of a sudden cattle are demonized? Cattle produce no more methane than do deer. They produce far less methane per pound than elephants or rabbits, or definitely horses or giraffes or wildebeest or gnus or any other herbivorous animal with a fermenting digestive system. Why are cattle demonized? But they said, let's get rid of all the cattle. Well, elephants produce more methane than cattle do. Let's kill all the elephants. Does that sound wise? And if you look at total methane emissions, fermenting livestock are such a small piece of that pie. The biggest source of methane, wetlands, rice paddies, any anaerobic environment will produce methane. So wetlands, which are a natural, they're a tremendously beneficial ecosystem. Do we drain all our wetlands to reduce methane? Do we stop growing rice? Well, maybe. Rice produces 18 times more methane per acre than what the cattle on a pasture do. And it's tremendous. And methane, when it goes into the atmosphere, is broken down by hydroxyl ions. And I see someone's already posting that. Methane is very short-lived in the atmosphere. Methane is not saying, because a methane molecule is worth 28 CO2, but it's very short-lived in the upper atmosphere. Also, pastures harbor, the cow emits methane, but the cow cash flows and the manure increases the cow cash flows the grassland. And the manure also increases soil carbon as well. It turns all that top growth into soil carbon. This tremendous grasslands of North America that had super high organic matter before we plowed it and started raising, plant food. There's your proof right there. Look at all the carbon that was stored in those grasslands that we got rid of by plowing. If we go to fake meat or something ridiculous like that, pea protein isolate, you want a crop that really depletes soil carbon, grow peas. Not to bash pea farmers. I work with a lot of pea farmers, but replacing prairies grazed by ruminants with peas is a huge step backwards, carbon-wise and climate-wise. And prairies have so many ecological benefits, it's not even close. Some of the benefits, people say we can produce far more food per acre out of cropland than we can out of pasture land. But they're not taking into account that these prairies, it's like they're not displacing nature. They are nature. They're wildlife habitat. They're natural habitats. It's about the only widespread means of extracting digestible, high quality protein from an intact native ecosystem. We can't do that growing peas for protein isolate to make some sort of veggie burger. Doesn't happen.
Dale,
Ruminant agriculture is where it's at.
So in your presentation, you said the S word, something very important to us at republicen.org, subsidies. Important in that we don't generally like them because we are very free market focused. And, if you look at some of the fossil fuel subsidies, for example, that have been on the books for 100 years, they went on the books to help a new industry or an industry that the government wanted to prop up, and then they never go away. Yes. And, you talked about federally subsidized crop insurance, yes. But, it's obviously no secret that a lot of different cash crops are also heavily subsidized.
Yes.
So do you see some sort of balance that's possible there? Maybe if you, if you want to get subsidized to grow soybeans, corn, whatever it is, you have to also take some of these other steps to be reasonable stewards of the land that you are.
I think so. We had subsidized crops because, in the 1930s, it's cheap food policy said cheap food, there are people that are going hungry. We need food to be cheaper. And so we said, let's pay farmers to overproduce so food becomes cheap. And when you create that overproduction, then the cost of, the price of a bushel of corn becomes less than what you can produce a bushel of corn for. So, we can't have farmers going broke. So let's make up the difference. So we encourage overproduction through this policy, but we'll keep farmers afloat by giving them handouts. And that made sense when the price of a bushel of corn had some sort of relation to the price of a box of cornflakes. Now, a box of, a pound of corn, and we're experiencing very high corn prices right now, historically, some of the highest prices in history. Although we also have the highest input prices in history, some by fourfold. But a bushel of corn right now is about 10 to 12 cents. And a box of cornflakes is $5 to $6. A 1 pound box of cornflakes is $5.60, and a pound of corn is 10 or 12 cents. So why do we still have a government cheap food policy when it doesn't create cheap food? There's very little relationship between the price of a commodity and the price of what you buy in the supermarket. So why do we have this Depression era legacy cheap food policy that makes farmers dependent, encourages overproduction so that we have a depression of prices, and then makes farmers dependent on subsidies in order to stay in business? Again, we created bad policy that remained.
Yeah.
And crop insurance is also one of those. It's desirable to keep farmers in business through, severe droughts. But when you have a subsidized system, then you get market inefficiencies, and you have farmers who learn to game the system. They say, well, hey, I can plow up this prairie that's on horribly rocky soil and grow corn for up to 3 years, and I get paid more for a failed corn crop through crop insurance than I do for a healthy pasture. I make money by destroying this ecosystem and collecting crop insurance. And to me,
I can feel our executive director, Bob Inglis, wanting to say some words. Bob, do you want to respond to this? I want to give you a moment before we adjourn. Maybe, are you muted? Hold on.
There, now I'm unmuted.
Oh, there we go.
Yes.
Okay.
What I think is so interesting, Dale, is the terrific comments in the chat. I mean, these
some
questions
good ones.
are
I've
just,
been kind of taking note there.
yeah, I mean, they're really coming. I mean, all of these folks that are asking such good questions and pointing out many corresponding things to the things that you're saying, it really is very exciting. And so the challenge that we identify at republicen.org, what would be government policy that would make it so that these things become economic? You talked about some of them with things like crop insurance. There may be others, and that's what, of course, we need to work on, is how do you make it so that if all that farmland can do that amazing capture that you're talking about, of course, it's got to remain planted. And so keeping that system going so that there's a reward for those farmers, something that makes it so it's economic. That's the challenge, of course. And so surely there's a way to incentivize that, to make it happen. And I think it's just very exciting what you're talking about. So Chelsea, that's all I've got to say, is just, but I wish we could go on for a couple more hours, because it looks like, Dale, you should teach a course or something, because look at all these questions and comments in the chat.
I do have some books for sale. So
okay, there you go.
Yeah.
Okay.
How's that for free market economy?
That's right.
And participants, we will take questions. We'll go through the chat afterwards and funnel any questions to Dale and make sure that you get answers to the questions that we didn't get to this evening. But I want to be mindful of the time. This is the first time we've done an evening podcast. See, I can't even say the word webinar, evening webinar. So here on the East Coast, I know my teenagers are like, keep hovering at the door. What's for dinner, Mom? And so we'll let our everyone go. But I thank you so much for joining us tonight. Thank you, Dale, for that spectacular presentation.
Thank you.
For our participants who are here
so much.
Well, we appreciate you, and just noting that we do these quarterly. So stay tuned for our next one, and always taking recommendations as well for this and for the podcast. And I'm looking at Ripe maybe as a podcast guest for season 5. So thank you everyone so much. We'll send out a recording as well after we compile those questions. Anything else, Angela? Nope. All right. Well, thank you all. And Dale, especially you, thank you so much for all you do. I'm glad we know you now.
Oh, thank you. I'm glad to be participating with people who are trying to make some change happen, because the alternative could be ugly. So.
Sure can be. All right. Thank you everyone so much.
See ya.
Thank
Bye-bye.
you.